Good afternoon, ladies and gentlemen, and please welcome to our stage, Hani Fuda.
Hey, good afternoon, everyone. It's a warm welcome from everybody. Thank you very much for taking the time. I know that we're standing between your lunch, right? And you're probably missing lunch as well. So I really appreciate the fact that you're here. And if you want to go quickly and grab something to eat, that's fine as well, right? Right? Because we are interested in your attention, your brain, and certainly a good topic, as you can see, the open software-defined automation. So I will invite the panel, our esteemed panel, to come over, and I'll set the stage, and we'll start rolling. Thank you. Thanks for coming. So before I introduce the panel to you guys, I just want to set the stage of what we're going to talk about today. You have heard it loud and clear during the keynote speak from Gwanel and yesterday, and probably also the rest of yesterday in terms of the session. We have made a big bet on open software-defined automation as a Schneider Electric. It's not only an industrial automation bet, it's also extending to the rest of the energy management in order to drive this open software defined automation. So it's becoming a critical piece of what we're going to talk about. And I think the reasons are clear. I mean, it's a fast growing space that in the industrial space is actually accelerating. The demands are becoming different. The responsiveness that industrial users or industrial owner operators must have in order to align with market needs, to align with regulations, to align with potential tariffs and so on, are driving everybody to start looking or to continue looking for ways in order to improve their productivity and adapt their systems much faster than what we have used and have done in the past. So the purpose of the discussion today is really how our leaders in the industry, are driving simplicity, how they are extending the freedom of choice around the various vendors that they are deploying in their plants, and how they actually adopting open software-defined automation in their operation in order to make it more resilient, more adaptable, more simplified, and enable the data gathering that would actually feed into some of the AI application that obviously are expected and we continue to talk about. So first, pleasure having you all here. I'll start by introducing from on my right. Start with Whit McConnell, who is with ExxonMobil, our chief engineer, automation and process control with ExxonMobil. Thank you for being with us, Whit.
You're welcome.
And then next to it is Arti Garg, who is the chief technologist for AVEVA, our software partner, and adding definitely as AVEVA a tremendous value from a software layering in EcoStruxure, and we will hear her perspective on software-defined automation. And then next to Arti is Balaji Iyer, who is industry leader for Americas for manufacturing industry with Microsoft. So you're gonna get a mix of flavors from certainly a very esteemed end user perspective, setting the standards around not only open standards, but around how the industry is evolving in the future, driving the push towards the industry, as well as Arti from her perspective, from an AVEVA technologist point of view, how this will evolve in the future and how it can be achieved using the various tools that we have. And Balaji from a Microsoft perspective, who's a very important partner in this journey for industrial, because obviously we use Microsoft stack everywhere we do in industrial automation across the globe, and you will hear from his perspective how Microsoft is playing a role here. So let's probably start with, I'm going to give you, if you don't know about open software-defined automation, and more importantly, why we call it open, not just software-defined automation. So just to give you an idea, the purpose, what we decided several years ago in Schneider Electric, that the industry needs to build smarter, faster, and more competitive solutions for industrial automation. The rigidity that we have lived within over the last 30, 40 years are no longer viable for the future. The adaptability that we need in order to change between computing power, change processing speed, decentralization, memory, and so on, is becoming increasingly important. We have talked to customers from automotive to certainly energy and chemicals, to pharma, life science, across the board, and we heard loud and clear from them that they want to have the ability to adapt, to change the production line when they need to, in order to quickly either to respond to geopolitics or demands or customer change in their tastes or directions that they see across the board. So we are seeing this momentum because companies our owner operators are trying to simplify and have a freedom of choice. They want to have a freedom of choice from the lock-in vendors that they have had for many, many years, as well as a freedom choice in really adapting their production capacity as needed, depending on the market demands. There's certainly the importance of having the scalability and the intelligence at scale is very critical for owner operators as well, in order to free up data. Rather than moving from a data that's siloed and locked in proprietary systems to data that is freely moving across the enterprise and across many elements of and many systems and many I would say solutions that they deploy in order to have the ability for better decision support and responsibility to adapt faster as required. And then the collaboration piece, which is basically once you move to something that is open and accessible, then you have a bigger ecosystem that can support you in the future, not locked in with a certain vendor. So I'll start the discussion, and feel free. We will have a Q&A as well, hopefully, that you guys can add color to that context. And I would love to hear from you, because I'm sure many of you would have their own thoughts and remarks. What is open? What is software defined? By the way, in terms of software defined, we're not talking about virtualization of a PLC or a DCS. We are talking far beyond that. We are talking about really adapting digital first approach in the solution, and it's a major strategic mindset shift, right? I mean, it's not just virtualizing a PLC or decentralizing control. It is a mix of all of that. So I'll start with Artie. From your unique perspective, how do you see industrial operation changing across industries, and how does open software-defined automation actually, fit and matter in that?
Yeah, no, thank you very much. So I think that as we sort of progress in the industrial space, software-defined automation is going to be kind of the standard or the way of doing things as we move forward. And really what's going to enable that is open data interoperability, because that's what allows people to really bring together their data, intelligence, and information from their operational systems to meet some of the mission critical objectives that allow, all of us in the industrial space to keep the modern world running. So for us at Aviva, we work with our customers to enable this through our Connect platform, because with our Connect platform, customers can bring together real-time data, operational information, and industrial context, and then apply to that advanced AI, visualization capabilities, so that you can make better informed decisions. Where I see this, not just now, but playing out in the future is in things like procedure automation. So I know Whit is going to talk a little bit more about that. But, what I think could happen next in this area is, as you can incorporate more data, let's say even service logs, you can start to see that we get beyond standard operating procedures that are developed through policy and implemented and automated through policy. But what if we could also digitally capture some of the knowledge and experience from people who maybe have decades of experience in how to really do things in the real world. And so if you can capture that, you can start to scale out capabilities that might otherwise be compartmentalized in one site within one set of experts across the organization. And so, I think this is really interesting because now this is automation that doesn't necessarily cut the technician out of the loop, but it gives them support. It gives them better advice from their peers along with contextualized information so that they can more quickly and confidently make decisions, especially if they have to address things in real time. So this is one of the things that I think software-defined automation plus that sort of openness in the ecosystem to allow interoperability might allow for the future.
Awesome, Marty. Thank you very much. And I think the context from a Veeva perspective is very important because you are dealing with many customers. Many of them are actually trying to, obviously you have, a lot of experience as a result of, the Connect and Pi. So you're seeing, you are actually ingesting a lot of data from various customers, and you're seeing basically the trend on how our owners, operators, the plant operators are really trying to get this data. So I think from my perspective, open software defined can help liberate this data and make it available to you, to some of the platform like Connect. So I appreciate that. Balaji, maybe from your perspective from Microsoft, again, the same question. Do you see this a trend in the industrial space? You are an industry expert, actually, in Microsoft. So you're probably talking with many owners, operators as well, about their view, what will be their pain points today in order to really feed into the enterprise level and help accelerate the decision from their perspective.
Yep. Microsoft prides itself in working with partners like Schneider in delivering value to our customers.
Right.
And when we talk value, there are two aspects to it, right? First one is, what are the pain points customers are facing today and where they have a directional benefit going forward? You already mentioned lock-in of vendors. I will also add a couple more, which is people want faster experimentation. They want faster design. They want modular designs that are scalable, upgradable. They don't want to get caught in that cycle. And the second thing is customers are looking for solving the talent gaps that will come in the near future that has already started coming. So in that regards, software-defined automation is an extremely important solution for our customers to realize the value from the shop floor. When we work with customers, we work across the value chain, starting with connectivity, but ending up to, as Aarti called it, decision support system. There are some sort of mundane tasks we would like to automate, but the critical process control tasks are still going to be with the operator at the end of the day. And we work with a broad range of partners. And that availability of partners and that acceptance of open standards, the mutual trust organizations are building with each other, that is what is critical, and that is what is driving open SDS adoption in the recent past. And I have a strong belief that it will only go up in the future.
Thank you, Balaji. I think it's very important that from your perspective also we need to continue to drive the industry forward, right? By as you said, this partner ecosystem will be critical in building this momentum around open software defined automation. And
yep.
We were talking before being on the stage. You're just coming from Rockwell, right? So I couldn't resist to mention that, right? Because you're probably hearing from their perspective. It's as an industry peer as well, what they are trying to do in order to move in that direction. I'm not asking you to devalue any information, but Microsoft is always in the middle, hearing from all vendors. But I can see the trend is gaining, right, from your perspective.
The value one creates for themselves should be far lower than the value that is created for the ecosystem.
Right.
That's when the technology will move forward, and we have the same belief, right? The industry has to move forward. People have to accept trusted partners and open standards.
Absolutely. Thanks. So with ExxonMobil, big owner-operator, you guys have been a founding member of Open OPAF, which is
In process.
Open Process Automation Forum. I remember that, from 2017, but it's always this acronym that is not moving forward when you mix it with Open Software Defined. So, but it's the same direction really for OPAF. As I said, 2016 was launched. You have been really leading the pack in that direction and really pushing the industry forward. Yep. What does open automation mean to you and certainly to Exxon? And in your opinion, what are the roadblocks and limitations that we have?
That's a great question. Thank you so much for asking it. So to answer this, I just wanted to put a little context into place. So I'm going to use a term that I heard this morning, which I thought was really cool. So I'm part of the silver tsunami. So that means I've been in this business a long time. So when I first got into automation, I started working on distributed control systems in the Baton Rouge chemical plant for Exxon at the time. It was before we merged. And these were just highly proprietary systems. They were very closed. You really couldn't communicate much with them. There wasn't a whole lot there other than the system itself, which was mostly electronics, right? We had just kind of moved away from pneumatic control to basic electronic control for PID, control of loops, and doing some supervisory control. Just getting into the beginnings of model predictive control, so a little bit of feed forward type stuff to help optimize plants. Even that stuff, the more compute intensive things were run on were DEC Alphas, DEC Corporation Alpha computers. So this is old stuff, right? So I saw then the evolution at the time was to move to what we call open systems architectures, which what that really meant was DCS vendors were starting to incorporate commercial off-the-shelf technologies, servers, workstations, running Microsoft operating systems at their core. And that was great. And you started to get this degree of openness through a standard protocol called OPC, which was OLE for process control, for those that remember. So object linking and embedding, which is a Microsoft DCOM-based communication structure that allowed for standardized communication between industrial compute devices. So think PLCs, think DCS, anything else that you would find in the field. Now I was there at the early days of OPC, and so in the early days, we called it Oh Please Communicate, because it just never worked the first time. And so it took a lot of working to make sure that it worked. It's kind of like the early days of plug and play, for those who remember that, the old USB standards.
Plug and pray.
Plug and pray, exactly. So I've seen the evolution of these standards, and now they're pretty good, right? OPC pretty much works seamlessly. OPC Classic, OPC UA we're starting to get into, and that's starting to work better. Plug and play actually plugs and plays, so it's all been pretty good. So you see the positive impact when we as an industry decide to standardize on how things communicate with each other.
Yeah.
Okay, so fast forward, and we are now well into the 2010s. Well, or actually early into the 2010s. And you mentioned we're a large corporation. Yes, we're a large corporation. And I have a very large fleet of DCS across my domains. And a large chunk of those were going to be obsoleted by the vendor within 12 years. Now, you might not get so excited about, oh, that's 12 years. Holy cow, we'll start worrying about it in 10 years and be done with it. But I had over 100 of these that were going to be obsolete in 12 years. Now, let me talk about what it takes to manage an obsolete distributed control system. When you buy a distributed control system to put into a new plant, it's not a cheap set of equipment. It's pretty pricey. If you open up the price book, you're going to get kind of walloped. But that's just the part of it, not even the half of it. That's the cheap part is buying the system, right? You have got to put it in. You've got to wire it in, wire by wire, to all of the instrumentation that's out in the field, all of your temperature instruments, your automated valves, differential pressure devices, all of your sensors and all of the valve movers out there. There's a lot of that stuff. So that's no simple task to do that and to make sure that everything's wrung out, everything's connected the way that's supposed to be. Then you have to design and program all of the control architecture, all of the control programming for all of that. Oh, and then you have to build the screens for the operators, right? And those are all built so that they know how to operate the plant. All of that is done within the vendor's particular ecosystem and their particular language, and it's really not transferable or portable between one system to another. It just isn't. Even within a single vendor's product line, you're going to see some differences between an older generation and a newer generation control system that will require elements of translation and having to take what's old and make it modern in a new system. If I go back and look at a lot of the systems that I had in my fleet that were going to be obsolete, a friend of mine used to call them Pac-Man graphics. Okay, so what we had in front of the operators were things that we developed in the 80s and in the early 90s, and they sort of look like Pac-Man. They did not look like Call of Duty, which is sort of what the modern stuff looks like. So you really can't just translate from one to the other. So you do all of that. That's really the expensive part, is all of the engineering. And oh, by the way, those things don't sit by themselves anymore like our old systems. They connect to a number of other subsystems like tank aging systems, process analyzers. You have to be able to pipe data up to your process historian. You're probably connected to alarm management systems. You're connected to advanced process control systems, model predictive control, real-time optimization like Romeo, and other things. And oh, by the way, we are becoming increasingly connected with our ERP systems and having to transmit data up so that we do get that connectivity, so we do get that visibility across the corporation and not just unit by unit. So they're heavily integrated into the site. And so to be able to move that from one system to another is very expensive. And at the time, our only solution was, I have an obsolete system. I need to rip it out. I need to replace it with the new system. And then I've got to do all the rewiring. And oh, by the way, I can't do this. I can't shut down my plant. That's prohibitively expensive. So I've got to do it while we're running. Okay, so imagine loop by loop, wire by wire, moving this thing from one system to the next, where you've done all of that translation, you've done all of the rebuild of the HMI graphics, you figured out how you're going to connect to your subsystems, your tank aging systems. You've got a console that's got emergency shutdown buttons on it. You've got radio systems. You've got P1 alarms, a lot of times in light boxes, and so you might be moving to more of a SHE VDU type of a system. All that's got to be moved over, and it doesn't happen in weeks. It happens in months.
With the high risk, of course.
With the high risk while you're moving all that stuff, and I have to double staff that whole time. 2 sets of operators the whole time, them able to coordinate who's got one on any particular day, because every day it changes. Okay, that sounded like a lot. I'm tired just talking, but the point is, one system takes a ton of planning and engineering effort to move from one to the other. So doing a rip and replace methodology to move from an obsolete system to a modern system was very expensive, and I had over 100 of them. And so when we went to corporate to say, hey, I'm not going to say the actual number, but it did have billions at the end of it. I need billions of dollars to be able to do this. And oh, by the way, it's going to take us 10 to 15 years to get it done. I was immediately shown the door. I'd like to say politely, but it really wasn't politely, and asked to go find alternatives. And so we did find some alternatives. We took a couple of strategic moves to do that. But one of those was to reimagine what a control system should be. If we're going to actually go through and have to rip and replace, I don't want to put in just another system that I'm going to have the same issue in 15, 20 years. Like, let's reimagine and define what the pain points are at the time, and let's start talking about how we manage it. And so the whole idea behind OPA came off of a bunch of whiteboards of us sitting around and kind of brainstorming and blue skying ideas around, gosh, wouldn't it be great if? And it kind of came down to that fundamental element of, what if things were built to standards more? What if we broke the paradigm of kind of within this highly engineered ecosystem within the DCS, if you looked at the fundamental components of I/O and control processing and networking, and you made those all standard, then you could like essentially commoditize those levels of a system.
Right.
And then you can start to drive that engineering effort up the stack where you're really going to be making money.
Whereas the IP is, I mean, the
Yes.
software application.
Yeah, today, as an end user of DCS, there are 5 or 6 major vendors. Schneider's one of them. And they all have a history, and it's perfectly normal that it evolved this way. But they have their own bespoke controller with its own language, with its own specifications, and it's highly engineered. They're highly reliable, highly capable systems. Absolutely are. But wouldn't it be better if I could let those interoperate, if I could exchange data more easily, if I could exchange control signals much more easily across a broader technology spectrum? That really does then start to supercharge what I can do with a new generation of control system. No longer am I just kind of confined to what the vendor can give me. And the vendors do a great job of listening to us, but the vendors have they only have X number of R&D dollars to spend every year. And so they have to figure out what's going to be the most marketable thing to spend on. And that's how they do that. And that makes perfect sense. But as a customer, I think it behooves all of us to communicate that, hey, we really need more. We really need a degree of openness so that we can participate more in a lot of the digital revolution, the AI revolution that's coming, while sustaining the high degree of reliability of these systems as they run our hydrocarbon plants, in my case. So to me, the job one is operator view and control. I have to have that 100% all the time. I cannot risk.
Yeah, otherwise you run blind. You run blind.
You run blind. You have to shut things down. It can be dangerous. There's all kinds of reasons why you have to have operator and view and control. The analogy I use to speak to people that aren't in this industry or in this business is to think about being on a Boeing 777 or an Airbus A350. That's right. Airbus. Sorry, I should have gone with Airbus first.
No, we're not French.
Knowing where I am. And you're at 36,000 feet, and someone wants to come in and do maintenance on the avionics.
On the avionics,
right?
yes.
Oh, we're going to do an upgrade. Like, oh no, not now. You're not. But that's what we do in the process industry. We don't land the plane when we're doing that work.
Yeah.
So it has to be it has to be there. So it's a long-winded way of saying,
no, we appreciate it.
The whole drive towards encouraging industry to adopt open standards was to solve some specific pain points around obsolescence. We think that having a standards-based architecture, a more software-defined architecture, gives you more optionality as you're traversing the life cycle of these various important systems. Whereas you were very limited before, and that made it very expensive. But it also supercharges what you're able to do within the ecosystems of those systems. And so we really looked at it both. I want it to be cheaper. I want it to be easier to maintain. I want it to be more powerful. So as a customer, I want everything.
Of course.
You've probably heard that before.
And rightly so.
I want it all.
You as a customer have you sign the check. I mean, we don't sign checks anymore, but in a sense, you demand the service and the flexibility and the openness from the vendor, and that's why the industry has to respond, right? I mean, and I think you drove into that direction, and you forced a lot of us, in our peers, not only us as well, to drive in that direction. So, but inevitably, you're changing the model for someone like Schneider Electric, and our peers, in terms of coming in, getting the installed base, and then milking the cow for the next 100 years, right? So, or 20 years for the DCS, which is exactly the disruption the industry needs. I mean, we probably the last industry within telecom, with respect to telecom, with respect to automotive, with respect to e-commerce and so on, that hadn't been disrupted this way. Right. So it's maybe the right time. So, no, I appreciate your perspective. Thank you very much. So maybe, Arti, from your perspective, sharing a story from what you have seen in the industry to illustrate the ways open software-defined automation is really helping overcome the challenges that WIT talk about?
Yeah, so I'll give one example and kind of talk both about what we're doing today and where I see things going in the future, because you asked me to give some future-looking perspective. So, we work in the data center industry, and, I think that, we work with data centers a lot at Aviva, and that's a growing area in the industrial space. And so Whit mentioned this notion about how do you do alarm management. So that's one area we're already working with some of our customers. They get these cascading alarms. How can they synthesize those and make better operational decisions? I don't know if you've ever been to a very large data center of any, probably a lot of people here have, but what you'll notice is on the campus, there's almost nobody. And so being able to take those data and make sense of them and make prioritized decisions around where to dispatch people is critical, because otherwise you won't be able to respond quickly to alarms. And so, that's one place where being able to take different data sets together is already helping our customers in the data center space manage things. But, where I think things are really going is particularly if you think about AI data centers. So, I think it's not a surprise. Everybody hears all the time how AI workloads and AI processors are increasingly power hungry. And what, you'll start to hear in the news a lot, and, electricity availability is becoming one of the barriers really to expanding the ability to deploy more AI workloads. And so this is where you're starting to see a really different kind of operability become really important, because what you need to do now is start to think about, how do I optimize my AI workloads against things like how much electricity is available, and how, what is my ability to cool the infrastructure on which those AI workloads are working. And so, we talk in the industrial space for a long time about IT-OT convergence. Here's a slightly different version of that, because now I want to think about, how do I optimize an IT workload, an AI workload, based on what my operational systems can deliver, and at the same time, how do I kind of optimize the performance of my operational systems, like the gray side of a data center, the cooling, the power generation, to enable AI workloads to run optimally. And, this is sort of a back and forth, because maybe what I might do is throttle some, if I'm doing a large training job, maybe I might throttle some of my computation at a time when electricity is really expensive. Or maybe if there's excess wind capacity, and this is, something that operators are already taking advantage of, I'll just, completely unleash my workloads across the data center. But, the more interoperable we can make those systems, and the more we can bridge the systems between, what the electric grid and the inside of a data center, the more we can really enable this sort of future capability and future workload. And I think, this is for me, it's really interesting, because in the past I've worked in the power generation space, and I've worked in, kind of AI computational, high performance computational infrastructure. And so it's really, to me, incredible just how fast this is all moving. And, my prediction is in about 2 years, just seeing how some of the infrastructure, the computational infrastructure is evolving, you're not going to be able to optimally run an AI data center without more open software-defined automation. It just won't be possible, because the resource demands, the power demands of these future workloads and the infrastructure that's supporting them will be too high. And you will have to just perform this type of optimization.
And I believe the same will apply for, in the industrial space as well, because you can throttle your process depending on your energy costs. Because I've seen some of our customers are looking into reducing some of the process intake or production, basically, when the cost of energy is very high, so that they can ship energy back to the grid, right? Because they're still running steam. Some of them have captive power generation and so on. So it's the same concept that you are explaining, Artie, from a data center perspective, is applicable for any process, continuous or discrete, because you can decide also how to shift your production planning based on the environment around you.
Yeah.
So as well.
Yeah, and we definitely have customers that are doing that as well, really, focused on energy optimization,
right,
and kind of managing their process controls.
So, Balaji, we talked about, you always talk about the fear of how, right? And how companies or owner operators can actually shift, because everybody is worried about being the first, right? Absolutely, and fear of change, because it's a dynamic shift. You also mentioned earlier about workforce, and we talked about the silver generation, in terms of the evolution of the workforce, and having certainly the new talent coming into the industry now are digitally native. I mean, they are playing the Call of Duty all the time. So they look at the what we see on the Schneider HMI and say, this is crap. I mean, give me something reasonable. I understand. So from your perspective, how companies can manage that change?
I mean, for me, two things, right? One is talent, which is the talent who thinks technology and technology device as an extension of human body. They are used to on-demand stuff. They don't want to wait. And they are perfectly comfortable with predictive algorithms determining their dopamine hit. So this is a generation that's going to be not liking the Pac-Man screens to tell them what to do. The second is, I'm also seeing where historically when companies ran distributed operations, they let some of them to be corporate sort of control, like governance practices, like the names, terminologies, like people management. They let individual plants decide what technology to use, what vendors to work with. As long as you give me my KPIs, I don't bother you. Be it a profit center plant or a cost center plant. But that's starting to change. Like now companies are saying, hey, are you ready for the next era? Like, how am I going to get data out of you? How am I going to have confidence of your security? So companies are starting to think about, how can we give a sort of a central architecture with enough vendor options for each plant at each geography, so that becomes sort of the common minimum program of a manufacturing excellence organization. So both of these eventually will be driven by high-end automation, moving people from sort of mundane tasks to higher order decision making, having them high quality visualization, make them feel that they are doing some high quality work. And with the current AI wave, people have gotten the confidence, I would say, to sort of lean forward on natural language-based interfaces, on more real-time analytics and insights being linked to be decided by advanced models. And all of this sort of, I would call is what's sort of changing in the ground. And then eventually we will need C-suite leaders to sort of accept that this is a change, and be sort of willing to experiment. Yeah, you might not commit as you like. You're not going to commit hundreds of devices to be changed just because you have to be ready for AI. But at least start experimenting so that when the time comes, your company has the confidence and the culture to actually embrace OpenSDA to drive the business results.
Absolutely. And I think the industry has a mandate naturally, because we need to build the next generation as well. So we need to continue to drive that and demonstrate the path forward is not an easy path, but it is the right path to go, right? In order to evolve in the right directions.
Cars moved from machines to software-defined vehicles.
Correct.
AGVs, AMRs, people have adopted those. Those were also sort of standard,
correct,
mundane machines. Now they are software-defined vehicles. Correct. So people are seeing it. They're just not feeling that, hey, my machines will also need to go through that change for the future. Right. It'll happen eventually. I mean.
Right. Okay. With maybe I come back to you regarding recently ExxonMobil received an award from the Open Group regarding best application adoption for a standard. Obviously, you're pioneering that. You're driving the path forward for one of the plants in Baton Rouge. This is a lighthouse project, so I guess you're showing that the technology is proving itself, right? Because now you reach a level of confidence to put it in an active operational plan.
That's correct. Yeah, so I said we've been on this journey for a while. So we've been through a number of phases of trying to demonstrate what we've been wanting and what I hate, this is an overused term, but the art of the possible. And so we've had a number of pilots, proofs of concept, et cetera, to kind of demonstrate the ability to integrate technologies from multiple vendors speaking with the same standards, and being able to interoperate as a system to provide view and control for a process. So the Lighthouse project was really the first at-scale hydrocarbon process to be controlled by an OPA conformant system, so a system that conforms to all of the OPA standards. We deployed that at the end of last year on a resins finishing plant in Baton Rouge, as you mentioned. Now this is kind of a turning point as far as I'm concerned. There's a big difference between deploying something on a plant or even on a small pilot unit. This is an actual plant. It's not a pilot. We're running it, and it's been running since the beginning of the year. Now, what's notable about this to me, as my VPs and presidents are asking me about the risk of going in with something like this. And by the way, I've got a lot of experience of putting in new versions of control systems and new generations of control systems. And we never, ever go with serial number one, like never. But this is serial number one of one of these. So there was a bit of a risk associated with that, right? And as much
we're praying every day.
I know. It turned out fine. But, you test these things in the lab, you have them, you do your factory acceptance tests, but you can never replicate 100% what the system's going to behave like.
Right.
In anger, at a site, with real operators behind.
Correct.
You just can't replicate that.
Yeah.
And so I did pretty much try to manage expectations that, like, hey, you can count on, we're going to have some some boo-boos, we're going to have some losses of you, we're going to have, it's just part and parcel of what we're trying to do. And we have to accept that as a business. But it turns out we had very little of that. There were some technical bumps in the road, to be sure. Some small losses of view on small parts of the plant, not on the whole plant. But in general, the system was relatively stable for serial number one of this type of a system. So I was at ARC in February, and I got on stage to say, hey, we did it. I've been talking to you for years about this, and we finally can demonstrate that we've put it on a real unit. And to demonstrate the reliability of the system's engineer responsible for making sure that system runs well every day was sitting in the audience in Orlando, Florida, a long way from Baton Rouge. So if that person felt confident enough to get on a plane and fly and be a week away from the system, that spoke volumes to me. By the way, I grew up as a systems engineer, so I knew exactly the calculation that person was making in their head about whether to leave that system and come over. So to me, that demonstrated that not only is this possible, but we can do it well, and we can make a system that's reliable, responsible, provides operator view and control, and provides the possibility to be able to do things that we've historically not been able to do. We've been looking at bringing in some technology that we would normally deploy at Purdue Level 3. And by the way, the whole concept of OPA kind of consolidates the old Purdue model. But things like video analytics, right? If I want to monitor a flare and I want to be able to alarm or alert on detecting that there's a flare or detecting if there's smoke, being able to give an opacity reading based on AI, running within a more advanced compute architecture that's a native part of the control system.
Right.
Man, that's great. That really demonstrates what could be.
Right. And Artie was talking about procedure automation as well. I mean,
procedure automation, all of that.
Yeah, fantastic. I'm just wondering if any questions from the audience as we, maybe to add a little bit of context, maybe your point of view.
Right. Hold it out. Yeah, like go there.
So my name is Niels Andersen from LNS Research, and thank you so much for your whole description of the history. I can very much resonate with that. I see a lot of focus on these open systems, and I think it's actually very interesting what is going on right now. I've been following the software-defined automation, following what Schneider is doing with universalautomation.org, and it's very interesting. I'm just looking for there needs to be a move forward in the industry. To what degree you talk about doing these pilots and so on? At what level do you see that the technology is going to be mature enough that you will actually jump onto these more new, open, standard-based technologies?
Wow, that is the million-dollar question. So I get asked this a lot. Like, when's it going to take off? So the way that I describe it to my management is imagine that, we're back in Boy Scouts or Girl Scouts and we're out camping and, you had to learn how to start a fire, by taking the stick and rub it. And you put the little leaves on there and you try to get, little embers to go and so we're in that stage, right? There's some embers glowing. We're hoping that it sparks and it takes off. We're wondering where's the tipping point when that's going to happen. But what I will say is ExxonMobil's kind of been in the front of this, like leading this, but there's no way we can do this by ourselves. And so what we really need are some first followers. And I know there are other companies out there, I've spoken with them, who have lighthouse projects that they're actively working. And so we're hoping as more players kind of get into this and start to see how they can leverage it within their own businesses, to see what the value potential is in driving to this, that's what really needs to happen. And so if I think about it from the vendor's point of view, so I talked to my vendor friends about all of this, we're in a chicken and egg phase. The vendors are wondering, how much of my R&D dollars do I need to sink into this? Do I go all in on this? And if I do, is there going to be a market, right? I mean, ultimate, people have to buy it. People have to specify that I want, my next control system needs to be OPA conformant. If we start hearing that, then I think the vendors are going to follow up and you're going to see this much, an iterative process that's going faster than it is today. Right now it's inching along because people are investing a little bit, seeing what kind of return they're going to get. Invest a little more, see what kind of return they're going to get. When the customer base decides this is the way to go and I don't want kind of the historical way we've always done things, I want to index towards a more open, interoperable system. They will have to mature, right? You're jumping on a maturity curve. So if I spec out an OPA conformant system today, it's probably not going to compete against a heritage system and all the R&D dollars that it's been to build that up, right? To the degree that our vendor friends see that, well, okay, I see the way the tides are going and I need to either evolve my system to include those things and so that I can evolve over time. And so customers that want the old can have the old, customers that want the new can have the new. That's kind of where I see the vendor community moving towards, is more evolving their kit as opposed to creating new kit that's OPA conformant.
I think it'd be very helpful if we in the industry could almost create a roadmap, because it's a dance. There is give and take, and I see the risk, but it is an enormous commitment on both sides, and you need to have some level of confidence that you can actually, what are the pieces that need to be in place? Because it's so easy that, I've been on the technology vendor side for many years, and we have this idea, we build it and it will come, and it's very dangerous. You don't want to do that. You want to be very close to your customers and how you do it.
Right.
And on the other hand, I see, of course, the customers to commit to something is very hard to do until you've seen it. But I think enough that you know what is necessary to be successful. If not, it's never going to happen.
Right.
Yeah.
So as far as Schneider Electric is concerned, we are all in. So we are really pushing the boundaries, and we would like to see the vendor community coming with us as well. But I fully understand, and is where what you're saying is as well. This dense approach, a step approach, will happen. We've seen it in every other technology as well.
Right.
But you need someone pioneering from the obviously the owner operator side and also from the vendor community in order to push the envelope and the boundaries and build it up. Any other questions? I think we are extending beyond our time, so I apologize for that. It's just
bonus rounds.
An interesting topic. Bonus rounds, exactly.
Hey, so a question for Whit. As you know, one of the more expensive things when you're updating or adding a new control system is running wires, right? what's your opinion on using wireless sensors for control and automation?
Wow, I got asked this question a lot too. So wireless is something that we have been doing more and more of over the past many years, quite frankly. And so that's a journey, right? And again, it's like all of this. There's a trust that has to build up over time when you're talking about doing something as dangerous as process control. So AI is one of those things we're trying to develop trust in. Wireless is certainly another one, and so certainly for data transmission, we're pretty comfortable with wireless, and we've become more educated in what works and what doesn't work, and so that trust is certainly building. We have extended that to some discrete control, so for on-off type stuff, we feel pretty good about doing that wirelessly. We know there's PID algorithms that you can do over wireless protocol. That's not something that we've jumped into with both feet. We're looking at it. But the thing that I caution everybody about is wireless is a great tool in the toolkit, right? When you're looking at an automation project, there are absolutely some cases where wireless makes sense. It's going to save you money. It's fit for risk. All of those things. It's not fit for everything. Right. And so just because I can do something wirelessly doesn't mean I should. Right. And so in a lot of cases, it's like, well, we could do this wireless, like just run a wire. Right. In this case, it makes more sense to run the wire. Where I do see some elements is some of the things that we've been doing with smart junction boxes. Right. So where I can put IO in the field, and instead of running that copper all the way back to the RIE or to the control house, if I can consolidate that there on the unit close to where the elements are and just run fiber back, well, that takes a lot of the benefit of wireless away, because wireless prevents you from having to do that investment. But I can skinny that down by using smart junction boxes. So that's another tool in the toolkit.
Yeah. Very well. Thanks a lot for your engagement and the discussion. Just a reminder from some of the takeaways. It's not really a software defined unless it's open. That's how we see it. Open software defined automation is transformative. Definitely, you heard that from our panel. And finally, it's just not a technical upgrade. It's a mindset shift that we are driving towards. Thanks for your attention, everyone, and hopefully we added some value to you. I appreciate your time. Thank you.
Thanks.